Hey everybody, it's Tony from Adafruit, and welcome back to another stream tonight. So it's a busy night on Channel A or Channel Adafruit. And this time I wanted to start a new series on Raspberry Pi talking to Wi-Fi things, or like little Wi-Fi boards. So I just did a 4-part series on turning a Raspberry Pi into an internet thing, where it's just a device that has a web page and maybe has some sensors connected to it. And I'll put a link down in the description when this goes up on YouTube so you can go back and look at some of those old videos. So that was kind of neat to like turn the Raspberry Pi into, a standalone device that you can look at in a web browser and maybe control. But nowadays there are all kinds of neat little Wi-Fi boards. So you might have something like this guy. This is the Feather, let's see if it'll focus. There we go. This is the Feather Huzzah ESP8266. Or you might have one of these guys. This is the Feather M0 Wink 1500. So this has a neat little Wi-Fi chip from Atmel on board. Or you might even have one of these guys. So this is the brand new Feather Wicked or Wicked, which has a really fancy Broadcom kind of SDK. It's an ST micro chip on there. So real powerful boards. All of these boards have Wi-Fi built in, so they're really nice little microcontrollers. You can program them with the Arduino IDE, and you can talk to different web services. You can talk to like raw sockets and things like that. But I was thinking, it's not really obvious or clear. You've got a board like an ESP, like this guy. How does it talk to a Raspberry Pi? Like, how do you go from maybe having a sensor connected to your ESP8266 sending data to a Raspberry Pi, or like a Raspberry Pi reading data from an ESP8266? You can look at like examples of maybe how to talk to a web page or something like that. So in this series, that's what I want to go through, is just looking at, okay, what are different ways that you can have a little Wi-Fi board sending and receiving data with a Raspberry Pi. So you might imagine, like in your home, you have the Raspberry Pi as kind of like the hub for all of your smart home things. And then you could have all kinds of things like, maybe a proximity detection sensor, motion detection sensors in every room, connected to little Wi-Fi boards, and they can all be sending data to a Raspberry Pi. And then, we'll maybe look at interesting software you can run on the Raspberry Pi to do all kinds of cool stuff with it. So that's what I wanted to do here. And this will probably be another like 3 or 4-part series. And we'll start out with like real kind of simple, straightforward stuff and build on it from there. So this time, I wanted to look at the ESP8266, this board, and I'll show you I have a sensor connected to one, and we'll see a really easy way to have it send data to a Raspberry Pi. And there's actually almost no programming involved. On the Raspberry Pi especially, we're just going to use some really cool utilities, Unix utilities that you might have used before, but you might not even realize like how capable they are and what you can do with them. So let's just kind of dive in here and we'll get started. So let's see, let's jump to a different view. Let's go to this view here. So in the corner up here in the top right, so I have a Raspberry Pi. This is the Model 3, but you can use any Raspberry Pi. And then over here, this is the Feather Huzzah ESP8266, so the little Wi-Fi microcontroller. And connected to it is our favorite sensor, the DHT22, or it's actually the AM2302, a little temperature and humidity sensor, like low-cost little sensor, but really good example of, if you wanted to do a lot of different remote sensing around your house and sending it to the Raspberry Pi. So the goal of this stream is we're going to get this sensor that's connected to this Wi-Fi microcontroller to send its data to the Raspberry Pi just over Wi-Fi, like, no physical connection between the two there. And you could even support like multiples of these. So I could have, maybe a temperature and humidity sensor in each room that's kind of measuring, okay, what's the temperature everywhere for it. So just to get started then, and again, like I mentioned, I'll put links in the description below to all the links I mentioned, products, and any of the code also that we write. I'll put it up on a GitHub repository that we'll look at. But this is basically the board that I'm going to look at, the Feather Huzzah ESP8266. So we've looked at a lot, really popular, awesome board, very easy to use. Like you just plug it in, download and set up the excellent ESP8266 Arduino package. That's really awesome open source package that some folks maintain. Load that up, and then you can just program it in the Arduino IDE. So let's kind of get started. And maybe I should preface this too. So, like a subtitle for this series might be practical socket programming, because I'm going to look at like, okay, eventually we're going to go through how you build like maybe a little socket server in Python and how to send data to it. But just to start with, we're going to look at some interesting utilities and things. And I don't want to dive too deep into like, okay, here's the theoretical, and here's, how network programming works, and here's a TCP socket and UDP sockets, and what's all the different eccentricities and things you need to deal with TCP. I'm not going to get into that level of detail. It's going to be more about like, here's how you actually use these protocols and build interesting things with them. And if you want to go further with that, I highly recommend it. Definitely check out a lot of the different college courses you can see online. Look at like pretty much every university now has online courses. Look for like an intro to computer science networking course. They're all pretty much the same. They go through the same type of info. And it's really the cool thing about the internet is that the basic protocols, like how you're even watching this video stream of me right now, it's all pretty much unchanged from almost the 60s and 70s. So it's all built on top of these low-level protocols like TCP and IP. So these different protocols that over time they've evolved and they've added things, and they've added new protocols and stuff on top of them. But I think it's really cool that TCP IP. I think it's safe to say at this point that it is a massive success. That it has survived the test of time, and it's one of these just fundamental parts of the internet and eventually society in general. So hats off to the guys that created that. It's just amazing stuff they did. So okay, so let's dive into this then. And let's go to the Raspberry Pi. So I'm going to show you an interesting tool you might have used before, and it's a good way to send and receive data between two computers, like two machines running a Linux operating system. And it's a tool called netcat, and we'll look at real quick the little man page for it. And so netcat, it's basically a tool where it's like the Swiss Army knife of socket programming and things like that, where you can send data with it, you can receive data with it. You can't like talk to a web server, although I'm sure there are people that know crazy ways to use it to like download data from a web page. But it can basically open up an internet connection to a server, send and receive data, or it can sit and listen for data to come in for it. So let's go through, and I'll kind of show you on the Raspberry Pi. So the goal of this is I want the Pi to be able to receive data, and I'll show you how we can use netcat to create a little basic server. So like without any code at all, we're just going to use this utility. And you don't even need to do anything. It's installed by default in Raspbian. I've loaded up the latest Raspbian Jessie Lite operating system on my Raspberry Pi, but pretty much every version of Linux, I'd be amazed if it didn't have netcat installed. And it's the nc command is what it is. And you can see all the details if you run man nc. That gives you the man page for it. But the options that are interesting, so on the Raspberry Pi, I want to create a server, and there are two interesting options. So there are a ton of command line options for it, but the one that I care about is this -L option, which tells it that it should listen for incoming connections. And then what it'll do, if you just use -L, you give it a port number to listen on, and then when something connects that port, netcat will actually it'll print any data that it receives, and then if you type any data into the standard input of netcat, it'll send it to the device that it's connected to. And then the other connection, and then after the device disconnects, by default netcat will just quit. It'll stop. Like it takes one connection and then it's done. But there's this handy little -K option which says keep listening. And so after a device connects, it will, and that device disconnects, it'll stay listening, and so another device can connect to it. And actually two devices can connect to it at the very same time and send it data. So that's perfect for us because I want a simple little server that can run on the Raspberry Pi that my little Wi-Fi boards can talk to, they can push their data to, and I might have multiple of these boards. And so if I have netcat running with the L and the K option, it should allow all those devices to connect to it. So let's just run it. Let's run nc-L, so that's going to turn on listening, and then -K to say, keep listening after someone connects. Now I need to give it a port number, and you can pick pretty much any port. So the port, I think it's a 16-bit value, so like 0 to 65536, and basically it's it's just a unique number that identifies this connection. So on a machine, only like one service can listen to a specific port. So like port 8000, I can't have like 10 different servers all listening on port 8000. There's just one process that's going to listen to it. But you can have lots of different ports. And a lot of ports have like a standard associated with them. So like port 8080 is the standard unencrypted web protocol, the hypertext transmit protocol. So that's, if you're running a web server, you probably have port 80 open. And in general, most of the ports below like port 1000 or so have something associated with them, like web servers, email servers, stuff like that. So usually you want to pick a high number here, like, something like 5000 or above. So let's just pick like port 5000. That's, generally a good one. The cool thing is I don't even need to run this as root because, I'm just running as, I'm using this such a high port. It's not trying to use like a standard port that you might need to run as root with. So I'm going to run this, and it's going to appear to do nothing. So it's just like, okay, it's listening, but something needs to connect to it. And now what I'll do, since I'm on a Mac OS X machine, I'm going to open a new tab, and this is on my Macintosh machine, which also, because it has pretty much a Unix backend, it has netcat itself too, so I can run NC. I think it has a slightly different version that maybe has fancier features, but we're just going to use the basic things. Now what we want to do is we want to connect to my Raspberry Pi on port 5000 and then see what happens. And by default with netcat, that's actually the default behavior, that you just give it the address of the device and then the port number to connect to. And if you don't give any other command line options, it's going to go and try and connect to that device. So let's do that. Let's do NC Raspberry Pi, which that's the host name of my Raspberry Pi. And my router, it's running the OpenWRT firmware, so it runs a little DNS server that adds any device that registers a host name. It will let any other machine on my network access it based on that host name. Your router might not have that functionality. You might need to go find the IP address of your Raspberry Pi by looking in your router config. But I'll actually show you right after this a little trick to maybe make that a little easier. But okay, so we're going to tell it, okay, connect to the Raspberry Pi, and then port 5000 is what I want. And so now I'm open here, so okay, let's see what happens. I'm going to type hello from Mac and hit enter. And then I'm going to let's go back to the tab that has my Raspberry Pi here, and let's see. Oh, interesting. It is not showing anything. Well, and this is one little weird thing where there's sometimes buffering where like, I pressed enter here, but that might be not enough. Like I might need to send more data to get it to actually send the data here. There we go. See, it kind of showed up. So what you saw there is basically sometimes standard input when I'm typing stuff in, it gets buffered and it waits to send it to the program until it has enough data. And so you kind of see that there where it's like, okay, you're waiting for some data. I think there's some ways to turn off that buffering, but this is just a little demo. But you can see, okay, so whatever I typed on my Mac came over to my Raspberry Pi. And let's go, hello from Pi. Hopefully you see this. And we'll hit enter there. And we should see over here, there it is, hello from Pi. So this is on my Mac. So it's basically like a little chat program, and that's all a socket really is. It's just a pipe to send and receive data. And in this case, the data we're sending are just ASCII characters, like the text that we're typing here. And then the socket itself, it has a server that I need to connect to, and then the port associated with it. So what we've done basically is I've created a little server, and I have my Mac connecting to my Pi. And the cool thing is, let's actually create another connection. So I'll open another tab, and let's do the exact same command, netcat Raspberry Pi and port 5000. And so we'll say hello from tab 2. Oops, tab 2. Hopefully you see tab 2. So we'll give it some enter there to hopefully see it, and we should see this in a second. It's like I said before, like there's the little buffering that you see. So let me go back and actually send some more data. More data. Send some stuff, and eventually it'll show up here. But anyway, so you can kind of see like it's connected, and unfortunately the buffering kind of makes it a little bit weird. Okay, so that's cool. That's a success. So we're close. Like I know how to run a server here, and I know how to send it data. And actually here I'll show you another way that you can send data with netcat. So I'm going to close, and actually you can see I killed the server over here. I hit Control-C to stop netcat, and both of these stopped because they realized that connection was closed, and so they said, oh, I'm done listening here. So actually let's run the server again, and I'll show you another way to send data. Instead of opening it and interactively typing it, I can actually pipe data into netcat. So I'll use a little Unix kind of technique called piping, where you can send the output of one program into the input of another. So if I use echo and say hello world, that's just going to print out hello. Oh, this is always kind of funny. I always do this. When you use double quotes and you have an exclamation in it, sometimes Bash tries to interpret that, so use single quotes. That always trips me up. So we say hello world, that just prints out hello world. But if I put a pipe character there, that's going to send the output of the echo command into whatever command I put here. And if I run netcat and say connect to Raspberry Pi port 5000, then this should send hello world to the Raspberry Pi. So it's going to connect to it, and it's going to send the hello world over here to it. I'm not sure why it's taking so long to connect. There might be something up with my network right now. So, okay, I think it finally finished. Yeah, there we go. So it finished over here, and then I just went away as it came in. So there's the hello world. So you can see, it's pretty straightforward. You can just echo some output and then use that pipe character, which sends the output of that command into the input of this command. So hey, that's the power of Unix. A bunch of little utilities, you chain them together. So that's cool. Like, we know how to send stuff from my Mac here. Now, the one thing that you saw, I used Raspberry Pi as the address, and like I mentioned, I can only do this because my router is kind of fancy and sees that I have a device with a host name of Raspberry Pi and lets everyone else on my network access it that way. And in general, this is kind of like a discovery problem. It's like, okay, I've got a Wi-Fi board. How does it know the address of the Raspberry Pi to talk to? Maybe I'm lucky and I have a fancy router and it lets me use the host name there, and it can do a little DNS lookup. But maybe I'm not that lucky. And are there alternatives? Are there ways that I can figure out or know the address of the Raspberry Pi ahead of time? And the easiest thing, I keep it simple to start with, is kind of my motto. The easiest thing, I think, is just to give the Raspberry Pi a static IP address. And so the IP is just like a fixed number that identifies every computer on a network. And so if I give the Raspberry Pi an IP address that it knows is unique and that it knows it's the only device that has that address, I can put that address in all of my little Wi-Fi devices, and then they'll know exactly how to connect to the Raspberry Pi, and you don't have to have fancy router or other kind of ways to discover the Raspberry Pi's IP address. So let's do that. Let's add a static IP to our Raspberry Pi. So I'll show you real quick too. To check your IP address, you can run the ifconfig command, and this is going to dump a whole bunch of data at you. But it shows each of the network interfaces. So ETH0, that's Ethernet 0, that's the Ethernet port, which is how I have my Pi connected. You might also see WLAN 0, that's the Wi-Fi network. I like to use the wired connection whenever I can. It's a little easier to set up. I usually recommend, especially when you're booting up a Pi to start with, you've got the chicken and egg problem of how do you configure Wi-Fi before you actually boot the Pi, and how do you connect to the Pi. So just plug in an Ethernet cable. It makes it a lot easier. But the cool thing here is you can see, okay, here is the IP address of my Raspberry Pi. And actually, let's try this. So let's run our netcat server again, and let's try from my Mac now. So let's copy this IP address. So it's an IP addresses, they're 4 8-bit values, so 192.168.1.234, and you might even hear so that's actually an IPv4 address, which is kind of the old original version. And we kind of realized we've run out of IP addresses. There's a limit on how many numbers you can have in each of these bytes, and we've pretty much hit that limit. So there's a new spec called IPv6. Well, it's not very new. It's actually pretty old, but it's taken a while for people to latch onto it. And that's actually what you see down here is the IPv6 address. And this thing looks a lot funkier because it's much bigger. I think they're 128 bits long or something like that, or maybe even bigger than that. They're basically like a GUID. It's a very long address. So hopefully it's going to be a long time before we run out of these addresses. But this is just another protocol, another way to talk to devices. I'm going to keep it simple and use IPv4, but just something to be aware of. There is a difference there, and like I said, if you want to get deep into the networking details, definitely look at some intro to networking classes, and you'll learn all about IPv6 and all those things. So okay, so we've got our IPv4 address here, and let's go back and let's run the same command, but instead of using Raspberry Pi, let's put our IP address in here. And so we should see, so you can see it's pretty much the same. We still have to give the same port because the port doesn't really depend on the IP address. So let's hit enter. So, okay, so that fired something off. And then let's go and see, hey, there's hello world. It showed up immediately. And it's kind of interesting, too, that you saw how much quicker this was versus when I used the Raspberry Pi address. And that's because, like, my Mac actually had to go and figure out what IP address does Raspberry Pi map to. And it actually uses a tool called NSLOOKUP, I believe. So if I do NSLOOKUP Raspberry Pi, that actually tells me, okay, it goes out and there's a special protocol for figuring out, what's the IP for something with a certain name. And it went and it queried the DNS server, which is my little router. And my DNS server said, oh, okay, I know a device named Raspberry Pi. It has the address 192.168.234. But you saw here, I can just use that address directly. It doesn't even have to do that DNS request. So it's a little bit quicker, just directly goes to the Pi and sends it the data. So that's kind of cool. So, okay, if I can control this IP address, then I can know ahead of time how to talk to my Pi, because I know that IP address is going to be the same. Now, the one thing is, for most routers, they give you a dynamic IP address so that if I reboot my Pi, I might not get this IP address again, this 192.168.234. And in fact, like another device might come on my network later and get that IP. And so, it's if I had hard-coded my Wi-Fi board to talk to it, suddenly it's trying to send data to, maybe like my Xbox or something like that, which, that would be bad news. So what you want to do is you want to set a static IP address where the Raspberry Pi says, hey, router, when it connects to your router and it tells your router, okay, I want this IP address, here's my IP, and it needs a little bit of config, like there's some extra state that it needs to have, and the router will give it that IP address as long as no other device has that same address. So, two devices on your network can't have the same IP address because it's ambiguous, which device gets whatever packet you're trying to send them. It's either one might get it. It's almost random sometimes. So here's how you do it. And I thought this would actually be the easiest part of this tutorial, but it turns out it took me a little bit longer than I thought because this changed in Jessie. So in the latest versions of Raspbian, if you search for how to set a static IP address for Raspberry Pi, you're going to find probably old info that tells you to edit the etc. network interfaces file. So if you're looking at a guide and it says, okay, just edit sudo nano etc. network interfaces, this is wrong, unfortunately, because a lot of these guides will tell you in this iFace ETH0 manual, you can change this to static and specify the IP address. But in Jessie, they changed it. And if you notice these comments up here, there's another service, this DHCPCD configuration that will actually control the static IP address. So you don't want to edit this file at all. And if you're looking at instructions to say edit this file, they're wrong, unfortunately. Well, they're not. I mean, they were probably right at the time. It's just they're out of date now. And so this Stack Overflow question I saw actually has probably the most comprehensive description of how to do it. And I'll put a link down in the description below to this question so you can see all these details. But basically, to set the static IP address, you edit your etc. dhcpcd.conf, and you add this little bit at the bottom here. And it's kind of cryptic. I don't like this configuration. I kind of liked the old way to do it because it was very explicit. Like, here's my gateway address. Here's my name servers and stuff like that. It's different. It's not necessarily worse. It's just you have to get used to it. So, okay, so this is telling me to edit the file etc dhcpcd.conf. So let's do that. Let's do sudo nano. Oops. Let's see, dhcpcd.conf. And there's all kinds of stuff in here. This controls, so DHCP is kind of this protocol for when a device connects to a router, it can ask the router, like, hey, give me an IP address, because not every device is pre-configured ahead of time to have a static IP, because you don't want that. Like, if you bought a device and it was hard-coded with an IP address, well, what if you had two of those devices and you try and load them up at the same time? They're going to collide. So most devices use this DHCP protocol to ask your router to say, hey, I'm a new device, give me whatever IP address you want. Like, I don't care what it is, just give me one, and they'll do this exchange. So this kind of controls a lot of that process. But I'm just going to go all the way down to the bottom, and we're going to paste in the example they have here. Now, there's a little bit of stuff you have to tweak here somewhat. So I'm just going to, let's see, reformat this a little bit. So we'll put in exactly what they have, interface Ethernet 0. And if you were doing this over your wireless network, your WLAN 0 connection, you would want to change this to WLAN 0. So you can only give a static IP address per network interface. But in this case, I'm using Ethernet 0 or the Ethernet jack on here. Now here's where I actually specify the IP address I want. So you can give like 192.168.0.10. Now on my network, all of my devices fall within the 192.168.1 namespace. And even further from that, I think my router is set up so that anything with 100 or above is assigned using DHCP. So it's, things that don't automatically have a static IP address, they're going to get one assigned. Like you saw, my Pi had 234 assigned to it. So I don't want to use something like above 100. I want to use something a little bit lower. And like I said, you want to make sure that you don't have a device that already has this IP address. So let's just say 42. It's a good random number for this. Now this /24, I don't exactly know why they need this in the config. Maybe it's optional. Keep it in there. This is basically saying, like, I think this is the range of addresses. I'm not sure why it needs that, though. It seems a little confusing to me. Now this router is equal. This is actually your gateway address. And so this needs to be the IP address of your router. And you might need to look that up. Like, most routers have this fixed. For most people, it's going to be something like 192.168.1.1. So, try that if it doesn't work. Now, your name servers, this is how you can look up addresses, like, look up the Raspberry Pi address. It connects to this little name server. And usually you want to use your router's IP address. Most routers run a little name server on it. If they don't, you can also just use, Google runs a free name server that's 8.8.8.8, so super easy to remember. So you can use that, but I'm going to use my router because it makes a little more sense, just to keep it within the network here. So, okay, so let's save that, exit, and then let's reboot the Pi. So just sudo reboot, and when it boots up, we should see that it comes up using this new static IP address. So we'll give it a second here, and we should even be able to tell from my Mac. If I ping my Raspberry Pi, ping its host name, it's going to show me the IP address, and we should see that it changes. And actually, let's just try it right now. Let's do like nslookup Raspberry Pi, and let's see. So it's still giving me the 234 address, and that's because there's caching sometimes with DNS. So let's try like pinging Raspberry Pi, and let's see if this gives me an address. So no, it's trying to ping the old address, and you can actually see, like, there's no device that has this address. Like, my Pi turned off, and so it's obviously not using that address anymore. So let's cancel out of that. Let's just try the address that I assigned it. So let's do a ping 192.168.1.42, and okay, cool, we're getting a response. And a ping is kind of like a little, like a hello, or like a door knock, where it's a protocol where you can like send a little packet to a machine on the network, and it expects to get a reply back. And it's good for like checking if a device is up, if it's working, if it's responding, that type of stuff. So okay, so there's a device there. So let's see, let's do that nslookup again and see if it might still be cached, but hopefully we see the address change. Oh, no, still got it. So well, let's just SSH into our Pi. So SSH into Pi at Raspberry Pi. Clearly it has the IP we assigned to it, though, because we saw we can ping it. So we'll give this a second here. And oh, actually, well, this is going to fail. Okay, oh, now this works. So it looks like, yeah, it's working. I thought it would fail because it was using the older 234 address you saw up here. But actually, you can kind of see here, when it's telling me it added this Raspberry Pi and this crazy address, this SSH session is actually happening over IPv6 because it's using this different address format. So just a weird little quirk. But let's run the ifconfig command again. So we run ifconfig, and okay, now we see inet address 192.168.1.42. So perfect. Our Pi, it's been assigned an address that we control. So now I know every time the Pi boots up, it's going to have this address. And I can make that assumption, I can bake that into code for my little Wi-Fi board, so it can just assume that it should always talk to this IP address. And it's not necessarily the best thing to hard code the IP address. And in future videos, I want to look at other ways to discover services. But this is easy. It's simple, and it might be all you need. You don't have to get fancier than this. So again, let's just do our little netcat thing just to make sure that everything's working. So we'll run our netcat server. And now from my Mac, let's do, echo hello world, but instead of sending it to 234, let's send it to 42. And so now we should see, hopefully, that, hey, there's hello world. It showed up here. So cool. So all right, so that's working. So okay, so now let's actually do some code. and see how do we get this little ESP board to send its data to that IP address. And I'm going to keep netcat running on my Raspberry Pi right here. So we'll see, as I start sending data from the Pi, you'll start to see that it shows up here. So, okay, so I'm going to jump to the Arduino IDE. And right here, so I've loaded up, I installed the DHT library that we have. So that's just for this sensor here. You have to install that library. And I've loaded up the DHT tester example here. And I have it hooked up exactly the way this tester is configured by default. So the signal wire, this yellow one, is connected to pin 2 on the Feather Huzzah. And then the power is connected to USB 5-volt power. And the ground is connected to ground there. So, it's pretty easy to wire it up. And I'm just going to run this sketch here. We'll upload it to the board. And so this is going to flash the ESP, and you'll see it program here in a second. So, just writing it up to the board. And one thing I really like about the Feather Huzzah ESP, so it uses this little Scilab's USB to UART chip, and it seems to work really well with OS X. I'm using El Capitan, which has all kinds of weird problems with its USB stack, where sometimes I constantly have to reset my Arduino before I program it. But this chip seems to work perfectly. I've never had like weird El Capitan related issues. So, okay, cool. So that just finished. And now let's open up the serial monitor at 9600 baud, and we'll see this sketch basically every 2 seconds it prints out the temperature and the humidity from this sensor right here. So cool. All right, so now let's see, how can we send this data over to our Pi? And let's look at an example here. So let's go into the examples, and make sure also that you have the ESP8266 board package installed. There's a tutorial we have for this that I'll link to. And make sure you have the board selected, because you won't see these ESP examples unless you have an ESP8266 board selected. But once you have those selected, then in the examples, you'll see all of these ESP8266 examples. And if you go down to Wi-Fi, open up the Wi-Fi client basic example. And this is actually a really good example because it's very simple and it shows exactly what we want, like opening a little TCP socket connection, which is what our netcat command is listening on, and sending data to it and receiving data from it. And so that's perfect. That's what we want. And we just need to make a few little tweaks to it. So to make this work for us, we need to tell it our Wi-Fi network. And so for me, it's a little bit different. So I'm going to put in my Wi-Fi network 22.4. And then, of course, everyone gets to see my password here. No, it's a big secret. So, hey, everyone, party at my place. You can steal the Wi-Fi. No, you can't, actually. But okay, so that's going to connect to my Wi-Fi network. And then down here, so by default, it tries to connect to 192.168.1.1. And so that would try to connect to my router, which I don't want to do. But let's put in our Raspberry Pi. Let's put in 192.168.1.42. And then the port, we need to change this. So we want to use port 5000 because that's what our netcat command is listening on. And so this is going to print out. It's going to connect. If it fails to connect, it's going to wait 5 seconds and then retry. And that's good because you might want that logic. If your Raspberry Pi goes down, what's your Wi-Fi board going to do? Like, it probably should sit there and retry so that eventually when the Pi comes back up, it'll reconnect. And then once it's connected, so there's basically this client class that it's using. And you can use the client class. Anything you print to it will be sent over that connection to the server you're connected to. And you can also read things back from it. So like they're doing this read string until. Now in this example, I'm going to keep it simple and let's not read anything from the server. So I'm just going to delete the reading part. And then this printing part though, let's change this a little bit. Let's do a print line so it prints a new line at the end just to make sure that we see a new line for all the data we receive. And let's just print hello from ESP8266. So that's going to print it out. Then it's going to close the connection, so it's going to quit the connection that it created, and then it's going to wait 5 seconds and then loop back around and do it again. So every 5 seconds, it's going to connect, send hello world, disconnect, wait 5 seconds and do it again. So that's pretty much all we want just to start testing this out. So let's make sure our board is selected here. So yeah, I've got the right port, and let's upload it to our board, and hopefully we'll see that this works in a second here. So it's going to compile it, and then it's going to upload it. That's only one annoying thing about the ESP8266 is that it has so much flash memory that it takes a little while to program the board. And actually right now it's still compiling, so I don't know, maybe my CPU is busy or something. Or there we go, finished compiling. Now it's uploading. And so yeah, I think it's got like 4 megabits of flash, so it takes a little while to program that because it's happening over a serial link, and so serial connections, are generally slower than like a SPI connection or a little more direct connection. So okay, so we're flashing all the data. It's going, and in a second here it'll finish uploading, and then we'll open up. Okay, cool. So that finished, and now let's open up the serial port, and it's 115200 baud that we want. So let's open up our monitor at 115200. And if you've ever seen a serial monitor, weird junk like that, it means that you have the baud rate wrong. So it's waiting 5 seconds, and then it's going to connect, and it just did something, and it's waiting 5 seconds. Now let's go back and let's look at our server here. Look at this. Hello from ESP8266. And let's just kind of keep watching this. So we should see every 5 seconds. Look at that. Just new one came in. So that's pretty cool. We've got data from our ESP8266 going straight to our Raspberry Pi. And it's kind of nice in that, like, I'm running a server on the Pi, and I didn't have to do all kinds of crazy coding and stuff like this. Like maybe if I just wanted to monitor something, like have a window open and just know, like, here's the current state of something, I could have netcat running and it could do this. Another thing you could do, so I'm going to cancel out of this. And by the way, since I canceled this just killed the server. So let's just go back and see what's going to happen in our sketch here. So you can actually see already here, connection failed. So it can't connect. Because my server isn't running, so nothing's there to accept that connection on port 5000. But because the example code is pretty smart, it's just going to retry there. So just something to be aware of, that when your server stops, everything stops. But something you can do with netcat, so I could run this and I can actually pipe its output to another command, or you can actually redirect its output to a file. So if you use this little greater than sign, then that'll push whatever netcat prints to a file. And you might actually want to use 2 greater than signs. This means append, so that if that file already exists, it's just going to add new lines at the bottom of it. Versus if I just have one, every time I start this program, it's going to clear out the file completely and then save new lines into it. So if I save this, we'll say server output.txt. And so now netcat's running. I'm not going to see any output because that output is being redirected to this file as it runs. But if I go back here, I should see, okay, I don't see connection failed anymore. So it's connecting. And now let's see, I'm just going to hit Control-C and I'll stop netcat. And then let's just look at that file, that server output. And you can see there's the 3 hellos that we got from there. So that's a legitimately useful thing. Like if you just wanted to run a server to log some data to a file, then that's perfect. That's all you need. You don't have to get fancier than that. You don't have to, write a bunch of code and maintain it. Just use little tools like this. Netcat is a great little Swiss Army knife. Now there's one extra thing I was thinking, because my end goal is I want to have sensor data and I want to log it. Usually when you have sensor data and you're logging it, you want to log a timestamp with it, because I want to be able to build a graph that says, okay, here's how temperature looked over time. And I could have my ESP board try to figure out what the current time is. And that's difficult because the ESP doesn't have a real-time clock on it. So I could add one. It's going to cost a little bit of money. It could talk to an internet service, like there's a network time protocol, and it could figure out the time. And that's a valid option. You could definitely do that. It's more complex, though. You've got to add more code for that. Or since the Raspberry Pi is receiving it, I was kind of thinking, is there an easy way where the Pi can just add a timestamp to the data that it receives? And again, Unix to the rescue. We can use a neat little utility in Unix, and it's not included by default, but it's a tool called TS, or timestamp. And it basically, you send it lines of input, and it will write those lines of input to its output, but it'll add a timestamp to the front of them, and you can configure what the timestamp looks like. So if I pipe netcat into that, then it will just output for every line that netcat outputs, for each of these hello from ESP8266, it'll add a timestamp in front of it. So let's do that. Now to get this tool, you need to sudo apt-get install a package called moreutils. And I've already done this, so it's going to tell me that I have it installed already. But this is how you get the ts command. And if you run the man page, so man ts, this tells you about it. So timestamp input. And it's a great little Unix utility, again, where it's built to do one thing. So it takes in lines of input, and slaps a timestamp on them, and that's perfect. And there are other ways to do this. I was Googling around last night, and there are tools like awk that can do this, and they get pretty advanced, and we don't need that complexity, so keep it simple here. So we'll use this TS tool. Now I am going to copy out because I want to change my format a little bit. So it tells me that the basic thing is you run it, and it's going to listen on its standard input, and every time it receives some data, it'll print out and append a timestamp. And if I want to change the format of that timestamp, I can just specify that format in a string when I start the command here. So I was thinking that the data that I want my ESP to send, I want it to be a comma separated format. So for each column of data, think of it like a spreadsheet. There should be a comma that separates it, because then I can save that to a file and I can literally load that into a spreadsheet program. Like Microsoft Excel can load it, Google Spreadsheets can load it. You can load up a CSV or a comma separated file, and it'll have that timestamp at the beginning, and then you can just build a chart off of that really easily. So that's what I want to do. I want to slightly change the format. So the way that I want to run TS is basically I want to use a special format string. And what I need to do too is I need to think about, so I want netcat to send its output to TS. And so the way I do that is using that pipe character again. And you can hear my cat in the background too. She's a big fan of netcat, so I think she wants to chime in and give her input. So obviously too, my cat obviously likes netcat. I didn't even realize that. So, so anyways, I'll be here all night, folks. This is get these jokes for free. Okay, so NCLK 5000, let's run our server. Now we're going to use the pipe character because I don't want to use, the greater thans, because that only goes to a file, and I'm not going to a file. I'm going to another program, and so that's what the pipe character does. And in this case, I want to pipe it to my TS program, the timestamp program, and let's just run it as is. Let's not add anything else to TS. And so you can see, like, it's running, and it's, it doesn't even look like anything's happening. Actually, sorry, I forgot to add the -K. Let's do the -K. So you can see it took one connection and then it just stopped after that. So netcat does exactly what you tell it. And so now you can see what's happening here. So this is cool. Like, I'm getting my hello from ESP8266, but now you can see there's a little timestamp appended to it. So that's perfect. That's almost exactly what I want. But I want to slightly change the format a little bit. So I'm going to specify the format like they had in the man page, because I think this format's fine. Like, it's using, there's a C function you can use to format time, and so it uses the same kind of characters. Looks a little cryptic, but if you read the man page, it can link to more details on this. But basically, I can add other things here. So if I add a comma at the end of this, it's going to add a comma, and I'll keep everything else the same. So let's run this, and now we see, cool, here's, the timestamp, comma, and unfortunately there's a space that's put in here, and I don't know of any easy way to get rid of it. Maybe there's another utility you could run to get rid of that space, but I think it's okay because spreadsheet programs generally don't care about white space between the CSV values. But now that's perfect. So I've got a comma, and I've got my ESP8266 data here. So this is pretty cool. We're getting pretty close to what I want. So now let's do kind of the final piece. Let's add the logic to our Wi-Fi basic client example to read our DHT sensor and send its data over to the Raspberry Pi here. So it's actually pretty easy. We'll go back to our DHT sensor example, and I'm just going to start copying out almost all of the code here. So I'm just going to grab all of this code. This is just the setup code that creates the DHT sensor object, and so we'll just throw it right in here. It's maybe not formatted very well, but it'll work. And then inside of my setup, I need to initialize my DHT sensor, and so I'm just going to copy that out of the example here. And you just have to call DHT begin, and that's it. So we'll put that call in here. And then when I want to get a sensor reading, there's just some functions here you can call, like read humidity, read temperature. And read temperature, you can actually get it in Celsius or Fahrenheit. So we'll grab all of these. And then in our loop here, so after we connect and before we send data, I want to read the DHT sensor. So we'll put this code in here. And so we'll just format this a little nicely. And let's see. So it gets the temperature in two ways. It gets Celsius and Fahrenheit. I'm in America, so I'll delete the Celsius one. Sorry, Europe. And we'll stick with Fahrenheit for now. But you build it your way. You can do whatever temperature you want. You can even do Kelvin if you want, and have that. That's probably the proper way to do it. So okay, so there's the humidity, there's the temperature in Fahrenheit. These are just float values. So now all I have to do is just print those over to my server. So in the client, let's just do a print, and let's start with printing maybe the name of this device. So the first CSV or the first column, let's call this my ESP8266 underscore DHT, and we'll put a comma after this. So this will just be, you might think of it like if you're building a table or a spreadsheet, the first column should be the name of the device, because I might have multiple sensors all around my house. And so, this might be the ESP DHT, and maybe I've got, one in a different room that I could give a different name. And so it's just a good way so that for each line of data, I know this is the sensor that it came from. And then I want to let's print out the humidity. So let's print out H. And you can specify in Arduino how many decimal points you want after a floating point value, like the precision of it. And I think by default they do like 1 or 2 or something like that. So I'm just going to specify 2, because this sensor, it only gives you like 2 decimal points of accuracy anyways. And then I need to add a comma explicitly. So we'll do print comma. And that's just because each of my different column values here, they need a comma to separate them. And then I'm going to print out the temperature. So we'll print out the or the F temperature value. And again, 2 decimal places should be fine. And actually here, I'm just going to print line just to end it. So I'm not even going to put this. Oh boy, I didn't want to do that. Oops, I always hate on Mac when you hit the end key, it jumps sometimes to the end of the file, and it just makes no sense to me. It's like end of line, that's what I want. So anyways, okay, so this is, I'm going to print out the name of my thing, the ESP, the humidity value, comma, temperature value, and then end of line. So I don't need to put a comma at the end, because the end of line says this is the end of this line. So that should be it. I'm going to, I don't even need to save this. Oh, yeah, sure, let's save it. We'll say, about this is my Pi talk to thing, part 1. Say okay, so we'll save that, and let's upload to the board, and we should hopefully see. And let's see how if I'm feeling lucky here. If I we'll just look at the output on my server, and in theory, after it finishes flashing, we should suddenly start to see temperature and humidity values popping up here. So we'll give this a second. And it's okay, so it looks like it started to flash the board in the background here. So it's doing this little thing, writing 4 megabits of flash data. I think it's 4 megabits. Let's go back and see. Yeah, 4 megabits of flash data it shows here. So and when you think about it, like, the Uno has 32 kilobytes of space versus 4 megabits. And it's not 4 megabytes, it's 4 megabits. But that's a lot of, it's much higher than what, the Uno has. Okay, so I think we're pretty close to being done. I think it's almost done. So let's see, it's going to boot it up here in a second, and we should see, there we go. ESP8266 DHT, there's, the name of our device. There's the humidity, and there's the temperature. Now the big test, I'll blow on the sensor, and we should hopefully see the humidity spike and the temperature also increase. Let's see what happens here. And so we'll give this a second, because remember, our server, our client, it's only pushing every 5 seconds, so it's going to take it a few cycles here to pick up. So okay, there we go. So we see our humidity just jumped up to 82.84%, and our temperature jumped up to 73%. So that's pretty cool. Like, just with a few Unix utilities here, I've got a server running that's logging sensor data. Like, this is, you could spend a lot of work and build something in Python that does this, or you could run a few commands and get the same thing here. And I like this. I like the simplicity of this. You can make a little startup script that runs this netcat command, and that's all you need. I mean, you'd probably want to output to a file like I had before. So if you want to do that, you just add on the redirection here. So use the greater than, and we'll say my sensor data.txt file here. So I'll run this, and we'll let this thing kind of run. And actually, I'll show you another neat command. So as this thing runs, I'll connect back to the Raspberry Pi. So let's SSH in. And this is, I'll open another connection to my Pi. And so I'll show you a command that you can actually watch a file in real time and see as new data comes into it, what's happening. And if as like new lines are added to it, you'll kind of see them appear. And so we'll see here, like, here's my server output file. And so if I cat the file, That's going to print out, oh sorry, sensor data is the one I want to cat out. So sensor data, so this shows, here's all the readings. The tail command is a neat command. So let's look at the man page for this. Oops, not man tail. This command, this will open a file and it'll show you the last few lines of the file. And it's made for looking at log files, because a log file generally has like your most recent event at the bottom. And so you can use tail when you quickly want to see like, okay, what are the last few log events? Maybe something crashed and I want to see what's happening. But it also has kind of like a real-time mode. And I forget, let's see, I always forget the follow option, the -F option, where actually tail will stay running, and as new lines are added to your file, tail will print them out. So let's tail -F our sensor data .text, and now we see it prints out like the first few lines, but now we also see here, as each new line is written, it's printed out here with tail. So that's kind of cool, and that if I just wanted an easy way to view what I'm logging and see things happen in real time, you can use tail to do that. And there are other ways to do this. There's a command called tee, and let's see, let's look at the man page for that. And T, I believe, lets you write to like multiple places. So you could use the T command to write the output of your netcat command. You could pipe that through timestamp and then pipe timestamp into the T command, and T command could pipe to both a file like our sensor data.txt and to your output, like your standard output that you're viewing. So lots of different ways to do that type of thing. I like the tail command. It's kind of nice and easy to use for this keeping it simple. But I think that's it. This is exactly what I wanted to show. It's just, it doesn't have to be hard to send data from a little Wi-Fi board to a Raspberry Pi. Like, you don't have to start with like writing a server from scratch, because it's pretty complex to write a server, and to deal with one that can deal with like multiple connections and high load and stuff like that. So let's use a utility, and netcat isn't like a professional utility in the sense that like you're not going to run a web server that has millions of users. Hopefully you're not going to run it using netcat. Maybe you could though. It wouldn't surprise me if it's powerful enough to do that. That might be a fun hack to try sometime. But it, for my needs, like if it's just me in my home with my sensors, this is perfect. Like I've got, a platform already where I could have multiple ESP boards. I give them different names. They push all their data to my Raspberry Pi, and then maybe I have some process later that goes and grabs this file from my Raspberry Pi and renders it in a spreadsheet or something like that. Or maybe I just want to log these, historically to keep track of. So that's it. So that's part one that I wanted to show. And in future videos, I want to follow up and let's actually build a server. So, maybe in the next video or a future one, let's see what it would take to write kind of the Python equivalent of this netcat command that I've got here that's, writing files and adding a timestamp and stuff like that. And I'll show you Python actually, the standard library has some really cool stuff in it that makes it very easy to write little basic servers like this. So we'll see how to do that. And I also want to get into, dealing with like more protocols and things like, can you discover the IP address of your Raspberry Pi from your Wi-Fi board, stuff like that. So, this will hopefully be the start of another interesting series. Maybe if folks have questions, throw them into the chat, and I'll see if, give a quick scan here and see if there's any questions here. Oh yeah, so good point. So someone says you should hook up a temp sensor to an electric motor and run it at hot or low speed to see how it changes. Yeah, in general, like, so I showed here in this stream how to send data from a device to the Pi, but in follow-up videos we'll look at how do you send from the Pi to the device, kind of go the other way there. And it's easy once you have a connection open. You've got this socket that's a two-way channel for communication, so you can just send and receive data here. So cool. So yeah, so I don't see any other questions. So let's jump back to the main kind of view here. So yeah, thanks a lot for watching. Subscribe to youtube.com/Adafruit. You'll see this video and lots of other fun videos up there. And then check out twitch.tv/Adafruit. You'll see me streaming live there. Also check out, we just started streaming to Facebook Live, and I'm not streaming to it right now, but I hope to try it out in the future because it looks like a pretty cool platform that and they've made it open and that you can send data to it from programs like Wirecast and hopefully OBS. I don't think OBS is supported yet, But I saw Facebook has an API, and I would hope that they add OBS support to that, because that'd be cool. But anyways, yeah, so subscribe. You can watch that live on Twitch. And then, yeah, like, comment, check out the Adafruit shop. That keeps everything going. So thanks a lot, everybody. And tune in. I'll be back Friday next week, so I'll be gone tomorrow, so that's why I want to do the stream earlier. But yeah, Friday next week, I'll do the follow-up to this video. So we'll do part 2. And then tune in Monday. I'll do another stream. I was thinking Monday I might do another follow-up on MicroPython on the ESP8266 board. So I did one this week that kind of, got everyone's feet wet and showed you how to burn the current firmware. But I saw there actually is really good documentation for the ESP8266 MicroPython port, and there's a lot of stuff they have implemented that I haven't even looked at before that I want to play with. So they've got like NeoPixel driver support, lots of cool stuff. So I'm going to come back, and maybe Monday I'll play more with it and see if we can do some more advanced MicroPython stuff. So thanks a lot for watching, everybody, and I'll see you guys Monday and Friday next week. So thanks a lot.